Hello and welcome to 6.1. Today we're going to be talking about roots and radical expressions. Our SWABAT is to find nth roots. Warm up, no calculator. So whether you did this on your own already or not, I'm still going to go over it with a little bit of detail. Find all of the real square roots of each number. So square roots we know looks like this. What we don't know is really for square there's like a 2 in there. So what we're looking for is the square root of 10,000, and 10,000 is the same as 100 squared, so my answer will be just 100. Here's one thing I'm going to tell you. When you're taking a square root of a number like this, you pretty much just need to cut the number of zeros in half. So because originally there was 4, there's only going to be 2. Similarly, if I had the square root of, let's say, 1,000,000, we're not stressing out about that because there's 1, 2, 3, 4, 5, 6 zeros cut in half. My answer should be just 1,000. Square roots. These are special cases. If I have a square root of 0.0625 and I can't use a calculator, I'm going to look at that 625, and for me, it triggers. What triggers to me is that 25 squared is equal to 625. So I already know that this should be something with a 25. The next question I ask myself is, well, if that's 25, what would it be for 0.0625? And just how for here we had to split the number of zeros in half, you kind of have to split the numbers after the decimal point in half. So there's 1, 2, 3, 4. So that means my answer should just have one number in front. So let's check it. 0.25 times 0.25. Well, I already know 25 times 25 is 625. But remember, you move it over 1, 2, 3, 4 places. 1, 2, 3, 4 places. And then I'm grateful because we get back to our original problem. Similarly, if I had 0.36 instead, well, I know the square root of 36 is 6. If there's two numbers, two number after the decimal point, then this one should have to move over half that amount of time at 0.6. Okay. Next thing, cubed roots. Well, instead of square roots, which would have a 2 here, a cubed root has the third root. So -343. Now, I'm pretty familiar with my cubes, and I know that 343 is like -7 cubed, meaning if I multiply -7 times -7 times -7, I get -243. Just kidding, 343. So this is the same as the cubed root of -7 cubed. These cancel out just like they do in the square root. We just don't always show that these are canceling. So I would get -7 for this one. Then you have your cubed root of this. So I take the cubed root of 1,000 over the cubed root of 27. Now I know 27 is a perfect cube. This is the same as 3 cubed. So I get 3. 1,000 is a great number because it's just 10 cubed. There's 1, 2, 3 zeros, so there's to the third power. So this will be 10 over 3. Let's try a couple more. Fourth roots. This means the fourth root of 256. So I'm thinking, okay, this is an even number, 2 times 2 times 2 times 2. That's not going to get me big enough. So I'm thinking, okay, it's got to be 4. So I check to make sure. 4 times 4 times 4 times 4. That's 16 times 16. So that is actually correct. So 4 to the fourth power is equal to 256, which would just be 4. Okay, if you haven't done so already, let's take a look at letter B, -625. I want the fourth root of 625, -625. Well, I know that 5 to the fourth power is equal to 625, but I need that to be negative instead. So what's -5 to the fourth power? Well, that actually ends up being 625 also. So there's no way, if this is even, for me to find this number. So I'm going to say no real solution. This, as long as this is even, That's like if I told you, well, what's the square root of negative 25? That's when you have to have your I. And right now, we're only dealing with the real roots, because if you look at the directions, real roots, just the real ones, not the fake ones. Okay, so no real solution or no real root for that one. And there you go. Anytime you have an eventh root, you cannot take the square or the nth root of an even number. Cannot be done. All right, let's go through a little bit of rules here. The real nth roots of a, let n be an integer where it's greater than 1, so not 0, and not negative. And let a be a real number. So if n is even, so cover this side up all together right now, then if a is less than 0, that means if it's negative, no real nth roots. So that means that's the square root of negative 25. That's the fourth root of negative 625. That's no real root. There's an imaginary one, yes, we talked about that, but there's not a real one. If a equals 0, well, what's the square root? Fourth root, sixth root of 0, always going to be 0. And then if a is greater than 0, you have possibly two real nth roots, the positive and negative. So what does that mean? Well, if this is true, then that means we can have a positive 4, but you can also have a negative 4. But we don't usually write that unless it has a plus and minus right outside of it. So we're not going to do that. Okay, and then here, only if this has a positive and negative outside already, that's when we carry it over. For the odd roots, that's the cubed roots that we saw for part A and B up here. That's like the third root, for example, fifth root, seventh root. Similar here, except now we can take the nth root, the cubed root of a negative number. We can take, this can be negative for anything. The only thing is, just like for here, it's going to take the sign that was already in here, because this is negative 7 times negative 7 times negative 7. So the answer is negative 7. So it works for odds, just not for evens. So an example of this is the cubed root of negative 8. That equals negative 2. The square root, fourth root, sixth root of 0, always going to be 0. So these kind of are saying the same thing. And then for a positive number, it's going to equal a positive number here as well. There is a little bit of notation here that we switch back and forth with. We have two different ways to say this right here. As an exponent, the nth root is 1 over n. So just like if I were to say the square root of 100, using the exponent notation, that's like 100 to the 1/2, which would also be 10. They both equal 10. If I had the cubed root of 1000, this is like saying 1000 to the 1 over 3, which would be 10, because this was equal to 10. So if I have m, let's say the nth root of m, I would have m to the 1 over n. That's what this is saying. All right, now if you could please, let's flip that paper over. I can't, apparently. Okay, now you can use a calculator, and so let's tell you about your calculator steps. Just to show you, like, we can probably do this without it, but I do want to show you just the calculator steps for this. So first thing I want you to do is hit the number 4, and then you'll hit math. Now this 4 is this 4. We're putting the power in 4 first. Works best for some of your calculators that you have. And then you're going to hit math. Okay, actually, before I say anything else, take one moment, press pause right now and write down these calculator steps, just so that you have them. So to do this, the first thing I'm going to do is put this 4, which is this portion. I'm just going to highlight. Just kidding. Yeah, I am. This 4 is this 4, and then this 0.8. This will change depending on what your root is and what your number is. So you have your calculator. So I'm going to hit 4, and then I hit math, and then I'm scrolling down, and I'm going to hit number 5 because this is the x. This is the xth root, whatever the root is. So I hit number 5. And then on mine it shows up like that. Your display might be a little bit different, but your steps should be the same. 0.0081. and then I can get out of there by just hitting the arrow to the right, and then I hit enter, and I have 0.3. 0.3. All right. And next, that's it. I thought I wanted to show you just calculator steps in case for those of you that didn't know it yet. You could also, if you didn't want to go through all that, you can use yep, I just lost a little bit of power. You can also use 0.0081, and then you can use a caret button, and then you can put it to the 1/4 power as well. Either way, you'll get the same answer. So with that, it'd be 0.0081, and then your caret button is right here, right. And then parentheses 1 divided by 4.3. There you go. All right. Here you are. Simplify each radical expression. Use absolute value symbols when needed. Now this part right here, they're only needed for even roots, and with the variable. We don't actually have an example of this now, but you'll see it more in later lessons. So that's just a note, and you might see it in your homework, so don't freak out. Okay, so the fifth root. So first thing I do, I'm looking at this 243, and I'm wondering, okay, what will get me to 243? Now you're going to trust me a little bit. I do a little trial and error in my head, and I believe that 3 to the 5th power is 243. And I'm going to write x to the 5th and then y. Now, before we've looked for perfect squares and we've looked for perfect cubes, I want a perfect 5th root. So this already is a perfect 5th root. Well, here, I'm going to show it out. I'm going to write these as each individual ones just so that you can see and follow along with me well. So for this first one, it's a beautiful thing because the 5s cancel out and I'm just left with 3. 5th root and the 5th, they go away. And then for these cancel out, so I just have x. That's all on the outside. But this, there's nothing for me to cancel here, so I'm just going to write it as the 5th root of y. And that's all that I can do for that. Okay, the next part is the cubes. We've got some cubes here. So I like to, if possible, write these as cubes. So 64 is 4 cubed, because 4 times 4 is 16, 16 times 4 is 64. X to the 9th, actually, it's like x times 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 x. 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm looking for cubes, so I'm going to group these together. This is x cubed. Here is another pair, another group, times x cubed. And then here's another one, times x cubed. When I add these up, 3, 6, 9, I get there. So and then 343 is 7 cubed. Okay, so if you're looking at these individually, I have the cubed root of 4 cubed times the cubed root of x cubed times the cubed root of x cubed times the cubed root of x cubed over the cubed root of 7 cubed. You do not have to write all this out. I'm just trying to show you where I'm getting it from. So these cancel out, and I have 4. These cancel. This would just be x, cancel, cancel, x, cancel, cancel, x. So how many perfect x cubes did I have? Well, I had 3 of them. X times x times x. Over, cancel, 7. And there you have it. Thank you very much for joining me. I hope that you have a wonderful day.